Hi, good morning, everyone. Thanks for being here, even though you partied hard last night, right? So my talk is going to be about the great 100G metro migration. I'm Susmita Adhikari, and as introduced, I'm from Cube Optics AG in Germany. So my talk will be regarding 100G migration for metro networks and basically looking into technical difficulties and how you can solve them, and probably looking into what future technologies are going to come up for 100G in metro. So let's start off with some typical numbers that you can already see out there from 2013. This basically shows you the figure, like how is the data rate increasing per year. And as you can see, for long haul, though the increase is very good, the metro only data rate is actually surpassing the long haul in long run. So we can see 3 times more growth in metro in the next coming 5 years. So that's why we see this move from 10G to DWDM networks, 10G, and now to 100G DWDM networks. And the metro-only traffic will grow nearly twice as fast as long haul from 2012 to 2017. To see more what's happening in a component business, so this is more like looking into the 100G components or 10G components or even below 10G components that have been sold over the years, and also the prediction what's going to happen over the years. This is taken from OVM from this year. What you can see here is this blue line, which is actually the 100G line, has a very steep increase. You can see a 34% of increase in CAGR from last year to 2019. And if you see, this is basically the revenue. So this is how much people can make out of 100G. What you can see here is actually the data rate, the components that is below 10G is actually going down. So it's like -6%. The 10G networks, the 10G components are still rising, but not as much as faster as 100G, specifically because people already have a 10G supporting network. What you basically need to do now is just to add more 10G with the DWDM wavelengths. So that's why you see this rise. But as you go further on, you will see that there will be need for 100G, and this is why the component revenue is now going higher. One more thing here is with the introduction of 100G, this is basically paving way for 400G, and this is what people have already been looking into technically for next coming 2 to 3 years, but only technically. Yeah? So how difficult is it to migrate to 100G? There's a dilemma right now for people because there are so many solutions available for 100G. Is this the right solution for me? What is the right solution for my network? And also the question, is it currently the right time to migrate, or maybe in 2 years? Should I still wait until 2 years so that they have a new technology that I can use with my network? Basically, I've taken this line from Andrew Schmidt from Infonetics. What he basically says is, today, if you are going to 100G, then basically the requirement for 100G is only if you have a WDM capacity that has already been filled up. So that means that you have a 10G network, a DWDM 10G that has already been filled up. So you need one extra line for 100G, or let's say your customer says, no, we want 100G right now. So that's the 2 situations when people are actually moving to 100G currently. And to look at what kind of 100G is the right solution for me. So this has been actually taken from ADVA. As you can see, there are various flavors of 100G transceivers available right now. It depends which distance you are looking into. If you are going to something like 10 meters, then there are 100G based CR10s available. Into more access networks, we can use SR10 so SR10 is still lower distances, but you can use LR4. The LR4 can then be used together with an SOA, a semiconductor optical amplifier, and this can again be used in a metro region. Then there's also a probability of using a 100G based ER4, but they are not currently in high production in market right now. Of course, in long haul, you have the DWDM 100G ultra long haul modules. That's why there's a question about what is the right solution for me in this area. What is the right transceiver? What is the right equipment that I use with my metro network? So what we are covering in this lecture right now is only looking into this specific area. I will be not looking into LR4 or ER4 together with a SOA. We will be basically looking into two different solutions. So one is called direct detect, and the other one is so famous Coherent, which has actually come all the way from long haul for metro region. Also, we will be looking into what different form factors are available. So there's a possibility of having CFP, CFP2. So there's a lot of questions right now. Should I be using direct detect or Coherent, or should I still be waiting for CFP2 form factor and make it a higher density network? So both of these solutions, the DWDM and the Coherent, they're basically working in the C band. The O band is basically for the LR4, and we will not be looking into that. Basically, with C band, you can still use your DWDM muxes. So basically, you would be filling up your older muxes with the new 100G lines. So this is the direct detect 100G module that is available right now in the markets. This is actually based in a very simple PD. So it actually has a nonlinear function between the electrical and the optical domain. That is actually the reason why it's also limited to CD, because you cannot do a chromatic dispersion compensation in the electronic domain. And it uses actually 4 times 25 gig optical dual binary modulation format, which is actually robust in the sense that it is still robust for chromatic dispersion compared to an NRZ, but it doesn't have so much robustness if you go to higher order modulation formats. So this basically means that the 100G is achieved by sending 4 28Gs. So this 28 is if you also have a FEC. So this is 25G, and you make it into 4 different wavelengths. And this is why you see a lot of here connectors. So this is basically 8 input. So it's 8, so 4 times in and 4 times out, but in 4 different wavelengths. And this wavelength is actually, it's in the ITUT grid, so it can be in 50 gigahertz or 100 gigahertz, because the 25 gig optical dual binary has a spectrum that can fit into 50 gigahertz grid. The thing with this direct detect is you can have it a fixed wavelength. So these wavelengths that you choose for your network can be chosen when you buy them, or you can have it in a tunable form. So you use a particular wavelength right now, and you decide, okay, maybe in 2 years I don't need this wavelength, or maybe I want to upgrade this wavelength. Then you use this wavelength with some other transceiver, but you can then tune this transceiver to work in a different wavelength where you would still like to get a 100G solution. This format is based on the IEEE 823.3BA. The power consumption for such a module is less than 24 watts, which is very important for metro network to be in a lower power region so that you are not spending too much capex and opex in power or energy. So as I told you earlier, this is already in production since 2011, and it's in higher volume, so it is easily available in the markets. And if you compare the price of this direct detect, then it's actually 20 to 30% cost of that Coherent, so it's actually very cheap. To go into Coherent, the Coherent technology is basically the receiver technology. It actually comes from the long haul, where basically people researched in Coherent because they wanted to go to longer distances before having amplifiers. So after the introduction of EDFAs, Coherent kind of vanished, but now it already came back again because of its linear behavior between the optical and electrical domain, so that you can actually use a DSP to compensate for nonlinearities. So that's the problem with long haul. So you have fiber nonlinearities, or so you can also compensate for chromatic dispersion and PMD and so on. So with Coherent, that you can also use a complex phase and amplitude modulation, and these phase and amplitude modulation, the information in the phase and amplitude is actually then linearly available in electrical domain, so that you can perform your DSP. With Coherent technology, you can have 100G in a single lambda. So unlike the direct detect solution, you will have a 100G signal in your one wavelength. It can be available in a tunable wavelength. The power, however, here will be higher. This will be around 85 watts, simply because you are using a DSP to compensate for chromatic dispersion, or even if you're going to higher modulation formats, then you also need to decode the modulation formats. So right now, Coherent is not yet available in a pluggable format. What you get right now is a line card that provides you a 100G solution. So you plug in your client-side transceivers, and then it can aggregate it, and then you have a Coherent output, but you don't have it in a pluggable form. You just need to buy the line card. For this kind of line card, to the transceiver to be available, it's going to be not until mid of next year, so 2015. This might be available. That's what the manufacturers say, right? So the price is still a question right now, because it's like 3 to 4 times that of direct detect. So the question, so the solution for moving to 100G is actually a question: do I have the budget right now for Coherent, or do I have the budget for direct detect? And is actually direct detect solving my distance problem, or do I really need the Coherent because I really need to go longer distances, or I really need to have or if I have a very bad fiber, which I cannot the parameters which I really cannot find out, then you can actually go for a Coherent solution. So they are basically what I'm going to show you here is trying to compare what different technical and economical or practical considerations that you have to do before you decide if I want a 100G direct detect or 100G coherence. In technical consideration, of course, there's a question of what kind of fiber I have. I have a very old fiber that has losses, like I cannot practically find out, or I might have 10G neighboring channels that actually also impacts my or impacts the 100G signal, because with a higher number of 10G neighboring channels, you might get some XPM or kind of a crosstalk from the neighboring channels. But I will not be looking into that, but I'll just look into these three topics, so spectral efficiency, dispersion, and FEC. What does spectral efficiency actually mean is that what is the amount of data I'm sending per bandwidth. So it's actually bits per second per hertz. And here the polarization, because with Coherent you can use 2 different polarization, so you're actually doubling your spectral efficiency. And what you see here, the red curve is actually for Coherence, and the yellow one is for direct detect. Since here you might actually already say, like, oh, I already have a very good spectral efficiency with a Coherence compared to direct detect. But what you have to know here is, as you increase your amount of data, or the amount of, so if you go higher with your modulation format, so if you go to 16 QAM or DQPSK, then what happens is that you require more power so that it actually can travel to 100 kilometers. While with a normal DQPSK, you can still work with lower powers and you can reach higher distances. Dispersion. So what is? I show you here a very quick figure here to explain what dispersion is. Dispersion is basically a linear behavior that comes from the fiber. So let's say you're sending a sequential ones and zeros. So after traveling a distance of, here I show you as L1, what happens is the time signal actually spreads out. So here you can still see, oh, I'm sending 1 and 0 and 1 and so on, right? So you can still decode what the actual signal is. However, if you plan to send this even further distance, then what happens is these pulses, they spread, and the information that you actually send 0 then becomes 1. So this is called intersymbol interference, and due to this behavior, it becomes difficult to know if you send a 1 or a 0, right? So if you're sending a normal NRZ signal, this is the kind of values that you would see. When you're sending, let's only see 10G and 40G, right? If you're sending only 10G, then the maximum amount of chromatic dispersion your signal can actually bear is like 1,000 picoseconds per nanometer, which actually relates to 60 kilometers. So with a 10G, you can already go to 60 kilometers. Now,
I'm sorry. So I remember 10G that today it's possible to have 1,600 picoseconds.
So this is for SSMF fiber, so maybe
this SSMF, which is
with 0.2 dB attenuation and 17 picosecond per nanometer kilometer dispersion fiber.
Depends on. I just remember because I had to do a link which was 80 kilometers, and I had to do it with 10 gig without any amplifications. I could get to DWDM modules, which were +2.
It depends which modulation format you're using.
No modulation, it was just a regular...
So it was a normal non-return to 0 or return to 0 format?
I mean, maximum chromatic dispersion acceptable was 1,600 picoseconds per nanometer.
So when you calculate dispersion, as you can see, it's actually picosecond per kilometer nanometer, right?
And in fact, it was working. I mean, it wasn't working for 84 kilometers, but for 82, it was working.
Yeah, so exactly. So it depends on what your chromatic, your dispersion parameter is. Probably it has a lower dispersion parameter. That's why you can go to higher distances.
Yeah, but this, I mean, this is quite secure. This is what you say.
Yeah, this is from the books where you are comparing a very technical solution for SSMF that has a 17 picosecond per nanometer dispersion, and yeah, you're using a normal NRZ signal. Then this is exactly what comes.
But in fact, in practice, it is possible to get 80 kilometers without any amplification and compensation.
I don't know if it's be possible to go 20 kilometers more, because that already looks like a huge difference when you see it's only 60 kilometers, right? But yeah, if you have some kind of electronic dispersion compensation, it depends what kind of signal and how much, yeah.
Okay.
So let me continue. So when you move from 10G to 40G, what happens is the maximum chromatic dispersion that can be tolerated by a signal actually reduces by a very big factor. So it's actually a factor of 16, because it's actually 1 over square of the bit rate. That's how it changes. And then the maximum distance that you can go with the 40G is only 4 kilometers. So if you think, oh, what happens to my 10G, then you can see you can actually not go anywhere. You'll just be in your transmitter, right? So that is why it's really important to have a chromatic dispersion compensation when you're comparing, when you have a directed text solution. And however, for a coherent solution, since you can compensate for dispersion in your DSP, that's why you can actually go to higher distances. Yeah. So the next question is if your system already has an FEC. So FEC is actually forward error correction. And what it does is it actually sends this redundant data. So when you're sending 25 gig, you're actually sending 28 gig. And this extra is actually also used for protocoling and so on, while some of it is also used for FEC. What FEC basically does is it looks into the redundant signal and says, oh, I can actually detect so much errors and correct so much errors. So this actually gives you a kind of a margin where you can, maybe you can increase your distance maybe by 2 kilometers or so on, right? Now coming to practical considerations. Practically, of course, the big question is how much how much is the budget for my upgrade? Do I have this amount of cost that's too high for me or too low for me? Then also the question of port density, energy consumption, which also leads to higher costs, and flexibility, which is more looking into the future. Would this technology still be flexible enough to maybe for next 4 years or 6 years that I have a new system, and does it work together with that new system? So here I have a very nice curve that I also got from OVM from this year. This actually shows you the price ratio between here, the blue curve is actually for 10G versus the below 10G transceivers. So you can see that basically the price is actually very constant for 10G compared to below 10G. So this basically means that the prices are not actually constant, but actually it means that the 10G and below 10G transceivers are actually going down, but they are going down in the same ratio. So actually 10G signals, transceivers are actually also going down in the same way, right? If you see the 100G for metro, then what happens is that the drop is not, the current situation is it's actually 80 times more than 10G. But normally you would just want it to be 10 times 10G, right? It's 100G, so 10 times 10G. But this is not actually the case right now. And people actually predict that the prices are going to go down in coming years. And there's probably people waiting for this prices coming down maybe until 2015, 2016. But it all depends on what solution you're looking for, because if you're going for Coherent, then, so this is actually an average of all the costs for 100G, including the direct detect and including the Coherence. But the Coherent is actually much higher than if you look at direct detect, then it's actually somewhere down here. Yeah, so and actually also the question is also about the complexity. As you go with Coherent, then you might have higher complexity in your system because you're using now a single wavelength to transfer your signal. That means probably you'd add more DCUs, or you might need a DSP in your system, so which actually adds more costs. The next question would be, do I want more density in my system? So that basically means that how much data rate I have per the area that I can use. So this here is actually CFP and CFP2 and CFP4 form factor. Currently, the DWDM version is actually in this form factor, so it's a CFP. We are still waiting if it comes in a CFP2 or CFP4 form factor. However, since the Coherent is not yet in a transceiver module, and as we can hear from markets, they are basically opting to go to CFP2, but here I have to warn you because CFP2 will only have the analog part of the Coherent, and the digital part, that's the DSP, then goes to the line card. So that would be more cost for your line cards as well. Yeah. So energy consumption, as I told you before, direct detect has 70% lower power dissipation compared to 100G. So for some service provider, this is already a good point to start because you're actually paying more every month. And one-time investment is also good for 100G direct detect compared to Coherent. So this is actually a very juggling act, I would say, that you have to look into what kind of technical requirements you have and what kind of budget you have, so you have to find an optimum solution. Here I talk about flexibility. Let me first talk about Coherence. The Coherent solution that, as far as we heard, as far as my information is that with the DSP outside, it's going to be a bit tough, that a Coherent transceiver is not going to work with any kind of switch or any kind of vendor. It's going to be a vendor specific. So the transceiver, this particular transceiver is going to work with this particular vendor and so on. So it's going to be tough with flexibility. However, with 100G DWDM, we have seen that various vendors have already accepted this, and What we have in-house also done is some DWDM testing, and we have seen that with almost all of these, it actually works. And we have gone until 20 kilometer, 80 kilometer, and even 60 kilometers. And this also together with DWDM 100G wavelengths. And it also seems to work together with existing DWDM 10G, which is actually a very important part because you're actually shifting from 10G to 100G. And we have already also done some long-term stability tests, and it seems to be working. So now I'll look into different network architectures that you can have to upgrade your 10G signal. But here I will specifically only focus into DWDM because with Coherent you don't have much option because you have to buy a line card and you have, so that's for us, we just leave it. So here I look at two scenarios. One would be when you already have a 10G DWDM signal running in your system and you would want to overlay with a 100G DWDM. So at the maximum capacity in this case, imagining that you have like 88, the highest number of wavelengths would be 88, then you would go to up to 1.6 terabit per second. This is because you have a 4 times 25, so this 4 actually takes 4 different wavelengths. So that actually means you're actually using only 12 times 100G. So, and then together with your, so this is then the 10G, then you have 40 times more 10G. And the number of transceivers in this case would be 52, so 12 times 100G, as I told you, because this is actually one transceiver, and then you have 40 times 10G, which you already have in your system. The maximum distance in this case would be less than 100 kilometers, but you would need an EDFA and a dispersion compensation unit for that. And the typical, the transceiver is still the DWDM CFP direct detect. The next option would be then if you fill up all of your 10Gs with your 100Gs with your your DWDMs with 100Gs, then you can have all of your 10Gs fill up as well with 100Gs. So then you would have all 96 channels of 100Gs. Then you could go up to 2.4 terabit per second, and then you could have 20. So then you would need 24 100Gs. So that would be actually only twice more, because if you've already upgraded so far, then you would only need twice more what you have done, and the distance would still be the same with the same transceivers. Here I would like to go a bit in detail with the structure, how that would look. Assuming that you already have a 10G system working and you have a 100 gigahertz DWDM mux, so this could be 40 or 48 or 44. So you're actually only sending this part of your signal. The best way for you to upgrade to a 100G, let's say you just want one or multiple 100Gs, would be then to have a different, of course you would need a different switch, and then you have a different mux here, then you would put all of your 100Gs together, and what you have to take care of right now after that is actually you would need this compensation and amplification. As you can see, you don't do this for 10G. Like you said, you said before, you can already go to 60 kilometers or higher with 10G, so you would not need anything like this in between for 10G. However, for 100G, you would need this kind of amplification and compensation. So you would need this intermediate stage before you put all of these 100Gs and 10G signals together with an interleaver. And this is a very particular scenario or practical scenario right now to move into 100G, so that you can still work with your 10Gs, do not disrupt this 10G services, and make way for the new 100G services. Okay, let me go a bit further here before I go there. So if you have already filled up all of your DWDM network here, then you can actually then replace this 10G again with 100G transceivers. However, then you would need such a compensation and amplification block here as well. So that would be more. That would be an additional modules that you'd have to add. What you can rather do is actually first move from, so then if you move all of this to 100G, then you could actually put them first together with an interleaver and move this block afterwards. So however, this amplification needs to have a higher gain because now it's working with more 100Gs, and then the compensation still works, the dispersion compensation. Looking into a different scenario, a scenario where you would probably want to drop 100G in your line, then here this is exactly the same as we had before, and this is also the same in the receiver part. However, you have a longer distance here. So what you can basically do is use an OADM in between, and this OADM actually has the wavelength so that you can actually get out this 4 × 25 from your 100G, and this you can use in an intermediate site as well. Am I too fast? Yeah. To conclude, so I would say 100G is actually creeping in slowly but steadily. So the choice right now you have is DWDM, direct detect, or coherent. The question is, of course, where are the costs for me? Where is the right solution compared to is it technically feasible for my existing 10G network, or is this budget enough for me? And of course, the weight is also for coherent pluggables, which actually makes things easier because then you can upgrade as you want to grow. And thank you for your attention. Any questions?